A stack can be implemented using an array which provides a simple and efficient way to manage the data. Here I am going to explain how it works along with its advantages, disadvantages and its applications. First, let us see what are the advantages of using an array for a stack implementation. The very first one is direct access. Arrays allow direct access to any element using its index, making operations like push and pop efficient, which with only with the constant time complexity, which is big O of 1 time complexity when it comes to push and pop operation. And the second advantage is simplicity. It is simple to use because this implementation is array implementation of a stack is straightforward and it is easy to understand. And third advantage is memory management. Arrays are contiguous blocks of memory which can be beneficial for cache performance. These are the advantages of using an array for stack implementation. And next is disadvantages of using an array for stack implementation. First one is fixed size. The size of the stack must be defined at the time of creation here. If the size is too small, it can lead to stack overflow. If it is too large, it can waste memory also. So, that is one major drawback using an array for stack implementation. And second one is it is not dynamic in size, which means no dynamic resizing is possible here. Arrays do not support dynamic resizing. Why? Because to resize you need to create a new larger array and copy elements from the old array, which would take a big O of n time complexity. And third one is wasted space. If the stack does not use the entire array, the unused space represents the wasted memory, right? For example, if the array size is 10, the stack size is 10, but you want to store only 5 data elements into it, which means the remaining 5 cells are getting wasted. So, that is also one of the challenge, one of the drawbacks in array data structure, like you implementing stack using an array data structure. And next is the applications of stack implementation using an array. First one is this can be used for evaluating the expressions and syntax parsing. For example, converting infix to postfix or infix to prefix, or to evaluate the expressions whether the parenthesis given or correct, and to for balancing symbols, and also the expressions when it comes to even postfix and prefix also can be evaluated using the stack data structure. And second application is function call management in recursion, which is used to keep track of the function calls and local variables in recursive programming. For example, consider an example where we are executing function A, but the execution but in the course of its execution, function A calls another function B. For example, I want to execute function A, but this function A calls another function which is function B. So, when the execution of A would get complete, when function B calling is complete, then only function A call would get complete, right. Then again imagine that function B turn again calls another function which is function C, then again function C which calls function D. So, in this scenario what would happen means when function A calls function B, this A is pushed onto the stack. Since function A is calling function B, this A is pushed onto the stack. Function A would be called into the stack. When the execution of B is complete, the system control will automatically remove A from the stack and continue with its execution. So, when function B is completed, when the execution of this function calling B is completed, this function A would be removed out from the stack, but function B calls function C, right. So, when the function B call would get completed, when the execution of C is over, the function B would get over, right. So, now function B would be pushed into its stack. Why? Because when the C is completed, the function B would get complete, right. So, until the C is getting completed, the function B should be pushed onto the stack. But if you check function call C, again it calls function D. Now, function C also would be pushed into the stack, because function C would get completed, function call C would get completed when function D call is over, right? So now the C would get pushed into the stack. When D is completely over, C would be popped out of the stack, and then again after popped out, which means the function C has got over, so B would be pushed out of the stack, which means B got over, then finally the A got over. So finally when the stack is completely empty, the function call is done, all the functions got executed, and finally the stack would get empty. So like you have to look at the stack after each function is executed, so one by one it would get fetched out from the stack. Once function D gets completely executed, function C will be removed from the stack for execution. The whole procedure will be repeated until all the functions get executed. So the system stack ensures a proper execution order of functions. Therefore stacks are frequently used in situations where the order of processing is very important, especially when the processing needs to be postponed until other conditions are fulfilled. And other application is this can be used in backtracking algorithms. For example, maze solving. Stacks are used to remember paths while exploring different routes in maze solving algorithms. Example is maze solving algorithms. And also this stack can be used for browser history navigation to manage the history of visited web pages using stacks. In conclusion, implementing a stack using an array provides a simple and efficient way to manage data in a last and first out manner. While it has the advantages such as directed access and simplicity, it also has limitations like fixed size and lack of dynamic resizing. Despite all these drawbacks, array-based stack are widely used in various applications, ranging from evaluating the expressions to function call management, and also for undo mechanisms. Also this can be used to implement undo functionality, where each change is pushed on to the stack and can be popped to revert to the previous state. Thank you.